The absolute value parent function is simply f of x equals the absolute value of x. It's the most simplified absolute value function you can have. It has a vertex of 0, 0, and then it's this V shape. On this side, the slope is -1, and on this side, the slope is 1. And just like with linear functions, you can transform absolute value functions. They pretty much work the same way. So, for example, if you want to move up or down, that's a vertical translation. So, g of x equals f of x plus k. You simply add or subtract however much you're moving up or down. The horizontal, you change the x value. So g of x equals f of x minus h, where h is the value that you're moving left or right. So, if we want to perform this transformation on f of x equals the absolute value of x, and we want to move it 5 units down, that would be a vertical transformation. So, g of x equals f of x plus k. So we're going to substitute in absolute value of x, and then we're moving 5 down, so that's minus 5. And if we want to graph that, then we just go down 5 to -5. And there we go. All right, now we're going to go 1 to the left, so that is horizontal. So f of x, g of x equals f of x minus h. So we're going to substitute in g of x equals x minus, and we're going to the left, so -1, which is g of x equals the absolute value of x plus 1. And to graph that, we are going to go 1 to the left, and the vertex is now -1, 0. All right, let's go 4 down. G of x equals the absolute value of x minus 4. And to graph that, we would go down 4, and our new vertex would be 0, -4. Okay, 2 units to the right would be horizontal. So g of x would equal f of x minus h. So h in this case is 2. So g of x equals x, absolute value of x minus 2. And when we graph that, we are going to go 2 to the right. And the new vertex is 2, 0. All right, the way that the graph shifts determines the vertex. So you can use h and k to determine the vertex. And if you know h and k, you can write a function for the absolute value. So, for example, if we want to translate this function so that the vertex is at -1, -3, we are going to take absolute value of x minus h plus k, and now we're just going to plug in the h and the k. So g of x equals the absolute value of x minus -1, which would become +1, and then minus 3. And then if we want to graph that, we just go down 3 over 1. And there you go. Okay, let's do another one. For -2. So we have g of x equals the absolute value of x minus h plus k. So we're going to substitute in 4 and -2. So g of x equals the absolute value of x minus 4 minus 2. And to graph that, you're going to go down 2 to the right 4. And there we go. All right, absolute value functions can also be stretched, compressed, and reflected exactly the same way you do the lines. So if you're reflecting across the x-axis, you make the whole entire function negative. And if you're reflecting across the y-axis, you just make the x negative. And a vertical stretch and compression, just like with the lines, you multiply the whole function times the factor that you are stretching or compressing by. If it's horizontal, then you multiply the x times 1 over the factor. So you multiply by the reciprocal. So if we wanted to reflect the graph across the y-axis, then you are substituting in -x for the x. So g of x equals -x minus 2 plus 3. So all we did was change the x to -x. Now let's stretch one, a vertical stretch. So that means that we are going to multiply the whole function g of x equals a times f of x. We're going to multiply the whole thing times 2. So g of x equals 2 times the absolute value of x minus 1, and then distribute the 2. So g of x equals 2 times the absolute value of x minus 2. Next up, we have a horizontal compression. So a horizontal compression, we multiply x times the reciprocal of 1/2. So that would be 2. So 2x, we're going to just plug that in for the x. So g of x equals the absolute value of 2x plus 2 minus 1. Next up, we have a vertical compression. So vertical means we multiply the whole function by the factor. So we're going to multiply the whole thing times 1/2. So g of x equals 1/2 times the absolute value of x plus 1. Distribute the 1/2, and we have 1/2 times the value of x plus 1/2. All right, last one. We are going to stretch this graph horizontally by a factor of 2. So horizontal means we're going to sub in for x the reciprocal of 2, which would be 1/2 x. So we're going to plug that in for the x. So g of x equals the absolute value of 4 times 1/2 x minus 3. So g of x equals the absolute value of 2x minus 3.